Dr. Rasky is an internationally recognized expert on advanced entry systems and thermal protection materials. Dr. Rasky spent considerable time at SpaceX providing expert consultation about the design and development of the heat shield for their Dragon spacecraft. As a result, SpaceX chose pica as the heat shield material for the spacecraft. On December 8th, 2010, the Falcon 9 rocket carried the Dragon capsule with its SpaceX fabricated pica X heat shield into space. It survived the launch and re-entry into Earth's atmosphere. Consequently, the mission was considered an enormous success. In addition to the SpaceX Dragon capsule, Dr. Rasky has made significant contributions to flight hardware used in 8 NASA missions, including the NASA Stardust Comet sample return mission. And I saw the video of that. It's quite breathtaking as it re-enters, and everybody's holding their breath right, because this thing's coming in really fast. Yes, it survived. And there was a big exhale. I think you said it was the fastest re-entry ever. And the Stardust return capsule,
yes, the fastest
entry ever. And the Stardust return capsule used a pica heat shield that enabled the mission and was the fastest entry ever made by a man-made object at Earth. It's now on display as part of the Milestones of Flight exhibit at the Smithsonian Institution in Washington. Pica also is being used as the primary heat shield for the upcoming Mars Science Laboratory lander mission. And today, Dr. Rasky is the director and co-founder of the Space Portal at the NASA Research Park in Moffett Field, California. Is that still true? Yeah.
Yeah, yes, it is.
Okay, yes. Yeah. And the Space Portal has a mission to be a friendly front door for emerging and non-traditional space companies. Through their initiatives and collaborations, the Space Portal has had a significant role in the establishment of several notable and successful NASA programs, including the Commercial Orbital Transportation System program, the innovative Lunar Demonstration Data Program, and the Commercial Reusable Suborbital Research Program. Now I know why they use acronyms.
That's how we use acronyms.
Yeah, it's a mouthful. Very fascinating programs, despite the long names.
And just so you're clear, yeah, I'm speaking now as Dan Rasky, private citizen. I work for NASA and have for 30 years, but in this venue, I'm speaking for myself only and not for the agency.
Excellent. So again, thank you for agreeing to this. And you've spoken widely about the use of more agile and lean approaches for spacecraft development. How widespread do you feel is this trend? And is it limited only to the newer startups, or is it something that you feel could be like used more generally by the industry?
Well, first, yeah, this was really spearheaded by this, we call it the COTS program, the Commercial Orbital Transportation Services, and with a companion program, it's called Commercial Resupply Services. And those two programs were actually put in place, the COTS program in 2006, and then the CRS program in 2008. And they were really the enablers for SpaceX. And Elon will agree to this, that without those two programs, SpaceX probably wouldn't exist today. He was already down to his last few shekels, you know, not able to pay his rent, as I understand, sleeping on, I believe, Larry Page's couch is at least the story I've heard. And in 2008, and he was down to his last swing at the bat to get a rocket successfully into orbit, and that was the Falcon 1. And he did that in September of 2008. Shortly thereafter, he was awarded a multi-billion-dollar contract to do resupply of cargo services to the ISS, and that was absolutely lifeblood for SpaceX at the time.
Yeah.
And then with that huge contract, he was able to put in place the Falcon 9 and do a number of additional, or do a number of flights, including to the ISS, and start taking payloads. And then the Commercial Crew program came along, which he also was a recipient of, along with Boeing. And although Boeing has still yet to, you know, have a successful demonstration flight for their Starliner vehicle, Elon has been flying Crew now since
I think about 2
20,
years.
yeah, 2 years at least,
Yeah,
2020.
2 years.
Yeah, 2020. And recently just flew the first all commercial crew
Yeah. Right.
mission, the Inspiration 4, completely paid for by commercial dollars, no government funding in that, and which is a huge milestone. Well, it turns out that since those programs, way back now in 2006, 2008, and particularly with the success of SpaceX, I think it has really now ignited throughout the agency that this is really an effective way to operate. And we're seeing more and more programs and solicitations using this public-private partnership approach, which we really pioneered with COTS and with the CRS programs. And so now programs out of the Human Spaceflight Directorate, things like the Commercial LEO Destination, CLD, which, big new destination points in LEO, for people to go to essentially take over for the International Space Station, the ISS. A number of programs in technology development out of the Science Technology Mission Directorate, and then even out of the Science Mission Directorate, like the it's called the CLIPS program, Commercial Lunar Payload Services, which intends to land a number of small cargo payloads on the moon, and then onto the human landing system for the moon, which NASA picked SpaceX and the Starship for that, which bowled everybody over. But all of those programs now, more and more, are using this public-private partnership approach, more of a metrics-based approach that, you lay either NASA or the companies or a combination thereof lay out a sequence of metrics, accomplishments that will be made.
Like
and
capabilities.
yeah, of things that will be developed, capabilities or other services that the government wants, and then a payment amount that should you accomplish that metric, and if you do, you get the money, and if you don't get any money, and
Right.
that is a really good motivator for performance. And by the way, the companies like it too, because if they can accomplish that quicker and at lower costs than what they negotiate with the government, they get to have a nice profit margin. So it incentivizes really effective, performance and behavior, and which is what we had in COTS. That's what we pioneered, and we're really pleased to see that percolating across the whole agency. Until the COTS program, most of at least the major space transportation systems were done under what's called a cost plus contract. And in many cases, a sole source cost plus, where the government essentially says, okay, we want to develop certain capabilities, and we're going to pay you whatever it takes, and so please do your best. And that does not incentivize efficiency or effectiveness, and because in that case, the government is shouldering all the risk, right? As far as okay, is this capability going to be developed, when, or for how much? And the company isn't shouldering any risk because they're getting reimbursed no matter what, literally no matter what they do, with a fee typically on top of it. And so that has proven not to be nearly as effective. And that was an approach that the government used for quite some time, going all the way back a lot of ways to the Apollo program and then the shuttle program. And it's actually a vestige of war capability activities, where the highest priority is urgency, getting something fielded quickly, and you don't have the luxury of going through a complicated competition and awarding. You want to get somebody working on a system right away because time is of the essence.
Just make this.
And make it quick, and it's more important we have it fast rather than
Liberty ships. Make these Liberty ships. Yeah, right.
Oh yeah. And so there's a time and place for that approach, but it actually, for a number of reasons, got, I think, overused, and particularly in maybe starting in the 70s and 80s, and so it kind of ended up incentivizing some regrettable practices on both sides, on both the industry side and the government side, because on the government side, you can kind of be sloppy with your procurements. If you're doing cost plus, you can have an idea of what you want to do, and the whole idea is to evolve it as you go. And on the industry side, well, they're getting paid no matter kind of what the outcome is. And so that has proven to be less and less effective. We actually did actually headquarters did a cost study on the COTS program and documented that the government saved a factor of 10 in development costs in developing the Falcon 1 and Falcon 9 rockets compared to traditional cost plus contracting, a factor of 10.
Factor of 10, yeah.
And we couldn't believe it at the time. Most other people couldn't believe it at the time. And what that does, and now these newer programs, I think they have embraced that, and they realize that they want to get as much bang for the buck, so to speak. And doing an effective public-private partnership allows the government to get a lot more, return from its resources. And by the way, the companies like it because it puts them in a position, just like SpaceX, of being profitable, growing businesses. So it was really a game changer starting back in 2006, and now it's really cascaded through most of the NASA procurement and most of NASA programs. So we're quite pleased about that.
It's kind of spread.
Yes, like at this point, like kind of like we joke like a fungus. Okay, it's spread.
Fungus, yeah.
started slow, but now has really kind of taken over. Most of the procurements I see coming out now from NASA are of a public-private partnership or a metrics approach, and fewer and fewer are the cost plus, and particularly the sole source cost plus. So I think that's for everyone, for taxpayers, for NASA, for the country, that's a good deal.
So that's fascinating. I have kind of two questions related to that. One is do you think that approach, where the the vendor has something at risk themselves, do you think that approach also might be applicable to suppliers of the vendor? So like SpaceX surely has suppliers. Can they use that approach too, or does it kind of only work at one level?
Well, let me just give you a story about suppliers. I heard this directly from Elon early on working with him. And he was explaining why he's gone to largely vertical integration at SpaceX. So rather than buying subsystems, he buys essentially raw materials and then starts with the raw material to fabricate all the things he needs. And he was explaining to me why. He says, when he first set up SpaceX, his intention apparently was that it would be largely what's called a system integration house. In other words, it would get subsystems from qualified aerospace providers, engines, tanks, structures, and integrate them together at SpaceX to build his rocket. And he said, but you know what happens if this is back in 2007, 2008. He says, you know what happens if you ask a qualified aerospace provider for a bid, on a subsystem? I said, no. Okay. He says, well, it comes back obscene in both cost and schedule. I said, oh. He says, but we're not done. He says, if you grit your teeth and say, okay, and sign up for that contract, when it comes time for delivery, okay, you'll be told, oh, sorry, the delivery schedule has slipped by some factor and the cost has gone up by some factor. And if you complain, you are told, well, you don't understand how aerospace is done. Because with a cost plus contract, you would just be passing these costs along to the government. Okay, right. You have a cost. And so he said, after having experienced that apparently, several times, trying to do this subsystem approach, his solution, Cliff, was to essentially go to vertical integration, go all the way down to where you have multiple raw material providers. And I know this for a fact when we were doing Pika. For Pika, we have, again, some raw materials. We have carbon tiles, we have phenolic, we have some materials. And we had to demonstrate to Elon that there were multiple commercial providers for all those components, okay? And only when you could show that was he comfortable to say, okay, we don't need to go any lower. That we have multiple commercial providers, now we can get a fair price on a fair schedule. And if someone isn't delivering, we can go to their competitor, so we can maintained, cost control of the supply chain.
Mhm.
So, and that's apparently how he's done it. And by the way, he's now with Tesla. I mean, he is a very, astute businessman as well as an incredible, technical expert. So, yeah, he's really pulled that together. So that's what he does. But you raise a good question, though. Could you do essentially what the government does on metric-based approach?
Mhm.
You would think so if you have, I guess, the thing is you have to have an alternative if someone doesn't produce. And sometimes the government has a little bit more flexibility there than a provider, particularly if they're under contract. And if they have a subsystem provider who doesn't produce, then they're kind of stuck. So,
Well, the reason I ask, what the kind of issue that I'm wondering about is, if you contract to a supplier for a part, they usually want very precise specs. But
right.
going to, what do you do if you want to change those specs? Like going back to an example that you shared in the interview that you published
Right.
some time back, where the heat shield specs for the strength of the heat shield. The heat shield needed to lean on the structure that it was attached to. So you and some others went and talked to the structure group, and you agreed right then to alter the specs. And what if the structure is being provided by a supplier? How is it possible to have that kind of more capability driven rather than spec driven relationship with a supplier? And I'm thinking if it's locked down because the supplier is locked into a price and to specs, whereas if they have money at stake, then they're more about the end result. I mean, what are your thoughts on that?
Well, I mean, that's essentially what you're just saying. The negotiating of capabilities is what happens at SpaceX. And yeah, that story, it actually was a little bit different. What happened is that the structures group undersized a bulkhead, and so that they needed, it's on the C1 on the first capsule going up. Okay.
Oh, so it was the other way around.
Yeah, they needed
Okay.
to reinforce the structure by having it push on the carrier structure for the heat shield. So the heat shield has a carrier structure and the heat shield's attached to it. And we had margin on the heat shield and the carrier structure. And so rather than redesign that bulkhead and refabricate that bulkhead, which would add, a certain amount of slip time into the schedule, they realized that they could just put a spacer in and have the bulkhead press on the carrier structure. Yeah, essentially share the load. And so, so we did the calculation, our structures folks, we had plenty of margin. And so they did that because that was just a quick fix. And you're right, that was how they were able to have a design issue that was quickly resolved, at least for that first capsule. And of course, then the next bulkhead they fixed. So, but that type of give and take within SpaceX is quite common. Okay, so, but you raise a good point. Could you do it with regard to suppliers? That's a little harder, I think, because you're right. Are they motivated by the same things? And one of the things that Elon has also done with SpaceX, he's very good at, I think, incentivizing good behavior from his employees. One of the things that he does, which is pretty well known, he doesn't pay that good of salaries, but he gives, or at least he used to give, quite a bit of stock options. And the whole point was that, okay, yeah, fine. You obviously need to live, you need to pay your rent and so on. So you need some cash flow, but your real payoff is going to be when the company increases its value. So everyone's incentivized to do things like, cooperate and try to make a success of the vehicle rather than trying to just guard your turf of your particular subsystem. And so that works very effectively there. And again, I'm not quite sure on could you get that to work with the suppliers? But it's a good question. Like I say, it definitely happens within SpaceX. Elon does, at least when I was there, very much wants to have multiple commercial providers at the bottom of his supply chain, so he's not held up by one supplier or another. But maybe that has evolved since all of his experience will go SpaceX and Tesla and Solar City.
At Tesla, and I don't know much about Tesla. I haven't researched them. But I know they partner with Panasonic for their batteries. That there's some kind of co-development going on with that. Right. So I wonder what that relationship looks like. I don't know. And
well, I know that one thing that did happen, okay, because it actually was starting to impact things when we were working. Actually, when we were doing the heat shield for Dragon, was when they were doing some of the first clay mock-ups for Tesla. And actually, in the big old facility they had down in Hawthorne, over in the corner, they had a tent set up that actually was the design studio for Tesla.
Really? On the SpaceX Hawthorne facility?
Yes, at the SpaceX. And they had like a sign and a little rope, okay, you know, sensitive, please do not, you know, pass this rope, but you could, and you could look inside the tent, and there was, I'm serious, a clay mock-up for the Tesla S, for the first one.
Oh, the S.
And
Okay,
yeah, that was really cool. And by the way, I still remember that because they had these talented, I guess, clay modelers, and they like to have their rock music up. So they would have their rock music up, and so it was a very different environment, very different work environment than the rest of the facility there. But yeah, I know that he really came up to speed with quantity production by working with Tesla, because you know in the aerospace you're building, you know, a handful at most, and you know with cars, oh my God, you know, you're building hundreds of thousands. And just so you know, I remember a couple of years into that, the R&D engineers realized that there were new big dogs coming on board, and these were the production engineers. Okay. And suddenly they were getting status, and Elon set up for the production engineers to actually have offices out in the shop, kind of up on the high level with all glass on their offices, so they could look out and survey all kind of the production facility at any time. So yeah, it kind of changed some of the dynamics there. The R&D engineers were no longer the clear top dogs. Suddenly the production engineers came in, and I know some of that production capability kind of then flowed into SpaceX on how can you rapidly produce these components and so on. So yeah, Elon does a very good job of cross fertilizing between these different entities. And again, he's I have to say, I've worked with a lot of folks, and he's a master at this. I mean, just unbelievable. So
yeah, I think they were using Tesla batteries. I mean, the entire battery assembly to to power the flaps on the Starship.
Yes. No, he cross fertilizes a lot. Okay, he's a very practical engineer, right? It's like, okay, I need this capability. What's the quickest way I can get to it? Okay, and if it means doing some cross fertilization from another of his companies or something else, they'll do it, and they do it really rapidly. And I mean, it's just amazing how quickly they'll pick up an idea. That's another thing I saw when I was there. It's just amazing. They'll hear about a technique or a new piece of equipment, get on the internet, get the details to it, find out who the developer or the provider is, do a search, get some of the components in house to do a prototype assessment of it, put it through its paces. If it looks like it works, integrate it into the design. I mean, and that can happen in a matter of just weeks from hearing about it to actually having it integrated into the design. And again, if I had not seen that with my own eyes at the time, I wouldn't have believed it. But I saw it multiple times that happen. Because at NASA, my goodness, okay, it would often take at least months, if not years, from where you'd hear about a new capability or new piece of equipment and all the things you'd have to go through before it was certified and approved for inclusion in a design. So I mean, they just short that down dramatically, and that's one of the reasons I think they've been so successful. And it still astounds people. It still astounds other aerospace engineers how they can be working new developments into their operational vehicles and so successfully. Okay, it's just, how do you do this? And they do it all the time.
You make me think of three different things I want to ask related to that. So I'm actually writing them down so I remember to ask them all, because they all pivot off of that. And one is the and so there was a story that you shared about previously about the heat shield material that
Right.
that there was a chemist who developed a matrix that I guess made the heat shield lighter. And it sounded like that occurred in the course of development, whereas traditionally you probably would have a separate research phase. And then later there would be, you would move that into, you would productize that, move that into development. But it sounded like this research happened during development. And so it sounds like
When
they
scale up, yeah.
integrate research and development to some extent.
Well, what they do, okay, research is probably a little too strong, okay, because they're really doing a development application. In fact, one of the things, and Elon will tell you this too, they actually rely on the government by and large, okay, to do any of the fundamental research, because what they want are really point designs and point solutions. And this is one of the things that I have been telling a number of my colleagues, and if the government or academia is not doing this, you can't look at companies generally to do it, because
Right.
they are really, bottom line. Okay, they need a point solution, and they really want the government or academia to do the low technical readiness, or what I call the sweeps. Okay, you're looking at all kinds of variations. Now they want to have the, if the government looks at 100 different materials and slight variations of materials, they want one or two for their specific application, and they're very thankful when the government has done that, so they can just come in and pick the one or two and not have to establish the material themselves. Pika is a good example. That, yeah, we had developed this material for Stardust. Now, what we did do when we were doing the tech transfer and scale up, because see, we made by the time Elon came in, we had made one heat shield, okay, about 1 meter for Stardust, okay. And now Elon, he wanted a heat shield for his 4-meter diameter Dragon, and lots of them, okay. So one of the big challenges for us is going from that initial Stardust fabrication process, which is really what I call lab scale, essentially the size of a coffee cup by and large. Okay, there's just to show you can make something useful that you can look at. That was the tech transfer. Then from there we had to do scale up, and the first scale up we had to do to what was called a full size billet. And you can buy the substrate material, this carbon fiber block, which by the way is used for vacuum furnaces. There's a big market for carbon fiber tiles for vacuum furnaces, which is great because we're using it for a different purpose, but you can buy these things. And so a full scale billet at the time was about 3 feet by 2 feet by 2 feet. Okay, so we had to go from essentially coffee cup size, right, to doing kind of the processing of one of these billets. Okay, and then once we had done that, and we did that with a prototype oven that we built specifically to do the final processing. And the final processing has to do with integrating in this phenolic. It's a polymer that turns it into a effective ablator. And then we went from making one billet to scale up to actually doing 6 billets in a batch. Okay, so those were really the technical challenges at SpaceX. 3 steps. Okay, tech transfer, lab scale up to a full billet size, and scale up to a batch, 6 billets at a time. And I don't even know where they are now. This is back in 2008, 2009, and that was plenty. In fact, actually, I remember at the time when we got to the 6 billet batch level, the structures guys were pleading with us to slow down, because suddenly they were the pacing element for the heat shield rather than the Pika. They had assumed that we were going to encounter difficulties, so they were okay.
The critical path flipped.
Exactly.
Yeah,
that old joke about running from a bear, two men running from a bear, and
right. You just have to run faster than you.
Yeah, I just have to run faster than you. Anyhow, so they thought.
And now I think now they're back to small tiles, for the Starship.
Yes, they are. Okay, and it appears, okay, and this is all speculation. This appears as another Ames tile. Just so you know, another one actually was developed under my tutelage as branch chief, and it's called Tuffy and Tough Rock. And we actually developed Tuffy for the space shuttle, and there's a whole story there on that. But it was developed for a space shuttle because remember, space shuttle used these reusable ceramic tiles,
Yeah,
and but they're very fragile. They're kind of like an eggshell. They really literally were like an eggshell
huh.
over a marshmallow. That's pretty accurate description.
Really? Okay, I didn't know.
Yes, pretty much, or over styrofoam. And so they, tons of repair work every time you flew the shuttle. I mean, that was one of those common refrains that, oh my goodness, the manpower to turn around a shuttle with fixing all these tiles. And actually, a couple researchers in my branch at the time, Dan Leiser and Dave Stewart, developed a much toughened tile coating that was called Tuffy that went on these tiles. Okay, so that was the first improvement. And then Dave Stewart actually developed a much higher temperature coating, a carbon-based coating that's called Tough Rock. And it appears, it appears looking closely at Starship that the Dragon scales are a combination of Tuffy and Tough Rock. Okay, so, and they made them larger and they made them hexagonal. They've made them so that they can be mechanically attached. I mean, again, that's what they do. They take a product and make it better, particularly from an operational standpoint. So no, it looks pretty impressive. And they were aware of these materials when we did the tech transfer for Pika. We let them know about kind of the queue of materials that were available for reentry vehicles. And just so you know, Tuffy and Tough Rock are also used on the X-37. So they are flight proven. And that's a classified vehicle, but that's unclassified information that you can find on the web.
Yeah, because I don't know about the X-37.
Yeah, I know.
Okay.
But trust me, the kids. So that they're flight proven materials on the X-37, and I think from everything I know, and TPS is again one of my areas of expertise. That's a good choice for Starship. I don't know of a better choice. So, and I'm sure he's got Pika on there, and there's also a kind of a version of something we called Circa, and that they called Zirca, Xirca. And there's a funny story to that too. But anyhow, yeah, so they're kind of using the whole queue of thermal protection materials that we had developed at NASA Ames, but using them very wisely and using them appropriately and improving on them, like what they did for Pika. They call it Pika X because yes, they improved it for their application, which, by the way, was one of the arguments for making Pika in-house instead of trying to buy it externally. Mm-hmm. And that was one of the arguments I made to Elon, which he was very receptive to, was that if you do this in-house, you'll be able to tailor Pika specifically to your usage. And he really liked that. Okay, oh great. I want to be able to tailor it accordingly.
Was that meeting that like your first week there?
Yeah, well, yeah, that's where Dan, what do you think? Well, right. Okay, let me tell you what I think, Elon. That's what we're going to do.
But about that, does that so an outside observer seeing that might think that Elon makes all the decisions and that he's like autocratic.
No, not at all. I don't know how to put it. He's really good at this. He's really good at giving people a lot of rein. Okay, here's the thing with Elon, and I knew this right from the start. Never make him a promise you aren't almost certain you can keep. Mm-hmm. Okay, with Elon, always under promise, over deliver, and then he's happy with you. Okay, and Elon is kind of a one strike you're out guy. Okay, so particularly if you make him a promise that you can't keep, and I've seen some people that just got really chewed up badly by doing that, including one of the guys who worked closely with us to scale up Pika. And he was always a ceramic matrix composite enthusiast, and he was looking at alternatives to Pika for Dragon and for, as it turns out, to be Starship. And he got into a group of materials that I had some experience with, and knew there was a track record of corpses behind these materials. And so, like, stay away from these materials. They sound good, but boy, people just don't come back when they go down that path. And this gentleman, he proposed this to Elon, and even though he'd done all this incredible work on Dragon, 6 months later, he calls me and he's no longer working at SpaceX. And I'm like, okay, yeah,
But is that because
But
he promised or because he didn't succeed in his approach?
my guess is that because he was talking to me about this and I was warning him, and his first name is John. John, be careful here. I've seen some really bad outcomes with people thinking that they can do this or that with this material and they can't. And I think I'm gonna give this a try. Like, okay, good luck. I mean, be really careful. Remember, Elon, he's he he is very unsympathetic if you make him a promise that you can't keep. That particularly impacts his schedule and his costs. And well, John did that apparently, and then wasn't working at SpaceX anymore. So
What happens if
he's fine?
what happens
But
if you say you don't know, but you think this approach probably will work, but you're not sure?
Then you're generally okay. Okay, but you have to be. In fact, actually, okay, that was a kind of the argument I was making when Elon said that's what we're going to do, and with regard to in-house peak, I believe you have to caveat things. Okay, here's what I know, here's what I don't know, and here's if I don't know for sure, here are the steps we can take to resolve yes or no, and we'll know. In fact, they're really good, by the way, at making guesses. And in some of my other videos, I talk about and joke about only somewhat that when they get to 51% confidence in an approach, they go, okay, but but they prototype it and check it. And if it turns out it doesn't hold up, they back up. Okay. But they do that with, okay, eyes wide open, right? Okay, we're going to try this. We're going to do these tests. We're going to prove it out. And if it doesn't prove out, then we'll step back and reevaluate. And I've seen him do that a couple of times. But what you got to be careful on, okay, so what John did in this case, I think, is that there was already a solution, and he was trying to propose a better solution, and my guess, he oversold it. Okay, because he liked these materials and so on and so forth. And as it turns out, they didn't work out, and now you wasted time and effort on an approach that didn't work relative to the baseline. So why did you just waste my time?
Right. Yeah. And there's no backup because you promised it would work.
You promised it would work. Okay. Yeah. And yeah, that's my guess. Okay. As to what happened. But he's very good though at giving people a lot of free rein, but weighing in when he needs to, and how he makes those judgments, I don't know. I've just seen him do it a number of times, but clearly, yeah, when he speaks, people don't question. People generally don't argue with Elon.
But does his style propagate? Like, do you see other people kind of emulating that?
Not so much, really. Okay, and again, I'll just give my experience. The guy that I worked a lot with was Tom Mueller, who was like one of the first handful, and Tom was just a sweetheart to work for. Okay, and also really good. I mean, really good at supporting what you wanted to do. Yeah, he wasn't quite as, well, that's off with your head as Elon. Okay, in the same way, Gwen. By the way, Gwen Shotwell is also, and I have to compliment Elon. I think that he is a good judge of his own strengths and limitations, and he, at least when I was in Hans, he surrounded himself with people who complemented his skill base. Gwen, okay, as far as interpersonal and organizational, she's just wonderful. Plus, just an incredible engineer herself, by the way. Just, I mean, first rate, and also business. But and same way Tom, a really good engineer, but he is much more of a come on, let's go get a beer type of guy. Much more personable. Elon is really, as he's mentioned, he's kind of on the
on the spectrum.
On the spectrum, and he knows it. And yeah, he's not somebody you go get a beer with. He's not. Okay. In fact, I've been early on. I was at a dinner. Actually, was at either right before or right after we made the COTS award, and it was Elon, probably Tom Mueller at the time. Tom is quiet too. And we're at this dinner with our friends from JSC down in Houston. And Elon, I don't think he uttered a word or two during the whole meal, right? And then we got to the strongman competition. I've got to tell you this one time. I'm going to run out of time here. When we were leaving, we got to the Elon strongman competition, which was, if I hadn't seen it with my own eyes, I wouldn't have believed it. Yeah, but yeah, Elon is someone that you talk business to, okay, and he's very effective and very efficient. And then he goes on. It's not someone you sit down over a cup of coffee, at least my experience, and just shoot the bull. Like, no, it's
What's the strongman competition? I don't know about that.
Okay, I think I have time to tell you this. This was incredible. It was at that same first meeting that I had ever crossed Elon, I think. And so we finished our dinner and we're leaving, and we were at a restaurant down in the Houston area, right on the coast. And there's between the restaurant and the parking lot, there was like this small little circus, okay, kind of set up, right? And so you had to kind of transit this little circus area to get to the parking lot. So there's like about 6 or 8 of us, including Elon, walking back to the cars. And we walked by this strongman competition, the thing with the big hammer and then the thing you hit and then the bell, right? And so we're talking, and Elon says, "Wait, I want to do this." And we all look at each other like, what? Elon walks over to the vendor and says, "What's your highest score today?" He asks the guy. And the guy tells him. Elon looks at us and says, "I'm going to beat it." And then we're all going, okay. And it was like $5 a try. He hands the guy $5. He takes the hammer, he hits it. He does pretty well, but he doesn't break the record. He frowns a little bit. He gives the guy another $5. He does it again. Still doesn't break the record. Gives the guy another $5. Does it again. Still doesn't break the record. He's up to like 6 or 7 times. Now he takes off his suit coat. Okay, he's working up, a sweat. And I'm thinking, how long is this going to go on? Okay. And then I'm thinking, he's going to be getting tired by now. I mean, his scores are going to go down. No, he starts now using physics. Okay, he starts changing his stance. He goes from from a two-handed swing to a one-handed swing to an overhand swing. He's using physics. How do I get maximum leverage? I'm absolutely serious. And he must have been up to like the 12th or 13th try. I'm not joking. Hits it, breaks the record. Okay. Walks over to the vendor, says, "Thank you very much," very politely, grabs his coat, and we go. And we're all looking at each other going, oh my God. Okay. Never go up against this guy.
You know what? I think he's going to get to Mars.
I couldn't believe it. I literally couldn't believe it.
Yeah.
Like, wow, he was going to break the record or die trying.
Right. Just like getting to Mars. He's going to get to Mars or die trying.
Or die trying. Okay, it's not like, no, I'm not giving up. And what's funny is that you're looking back at the social dynamics of that. He did this deliberately. He didn't go to his car and come back on his own, just see if he could do it. He made this pronouncement to us, okay? He made this as a challenge literally to himself for no reason. I mean, it wasn't like, what? He wasn't going to win a prize or anything. I think he got a stuffed animal or something. But this was something that he was doing in his mind. I guess he wanted to prove to himself that he could. And so he made it kind of a public challenge. I mean, it's remarkable. I mean, and the psychology behind that. And but I'm serious. After that, it's like, see, and that's when I realized, ooh, never promise this guy something you can't do.
So have you seen? I know you have to go. The current issue of Vanity Fair, which generally is a really horrible magazine, but they once in a while they have a fantastic article. And the current issue, they interview his current girlfriend. The one he had a second child with recently. Yeah. And she talks about him briefly and talks about what it's like to live with him.
Yeah, I bet it's interesting.
Yeah, you should pick it up.
Personally, my interactions with him, I've always gotten along with him very well. Okay. Mm-hmm. In fact, I don't have time to tell you now, I've even had a couple kind of heart-to-hearts about things, but I can see that he can be quite challenging for a lot of people. It wouldn't surprise me, and that's what I've heard. But yeah, no, I always got along with him well. he chose the right heat shield. Which he did. He listened well. I've always been just amazed at not just his technical skill, but his business skill. I mean, I've never worked with anyone like him, as skilled as he is. I haven't. And I've had a chance to work with some really skilled people at NASA. And one of the benefits, really skilled. But Elon, without a doubt, is at the head of the class. I'll just tell you right now.
Wow.
Just
Amazing.
astounding. He's astounding to work with.